Okay, so for this lesson, I feel like it's so much easier to do it with a chart. So I'm just going to explain the first one, and then with the other ones, I'll use a chart because if I explain all of them, it'll take a long time, and using the chart is so much easier. So I'll go ahead and explain this one. I'm going to draw my hexanoyl. So that's 6 carbons, and then double bonded oxygen, and a chlorine. And then I'll add my lithium to the canvas and my aluminum. And it's a hydronium workup, so I'll go ahead and add my oxygen, which will become a water molecule. Hit arrange and fit. I'm going to go ahead and move that hydrogen from the lithium to the aluminum. Hit arrange, and now I'll begin working on this molecule. So first thing, I'm going to release this bond from carbon and oxygen. That leaves this carbon with with only 3 bonds, so I'll move one of these over here. And then I'll go ahead and move this bond back in order to disassociate the chlorine. And then I can go ahead and attach this to aluminum, the water to aluminum, which will then make me need to release a hydrogen. But to do that, I'll remove the electrons and bring them back to oxygen, and then bring that hydrogen back. Hit arrange, and I'll move this molecule over. So now what we have left is this aluminum's happy, this oxygen's happy, it's neutral charge. This carbon is neutral charge, but this one is a negative charge. So I'll go ahead and take this this lone hydrogen, hit arrange, and that's the whole process. So it's a lot of steps. I know I went fast because I think the chart will be so much easier because you saw all those steps it took to get to this. But I'll go ahead and show you that now. So the end of this will be a carbon with 2 hydrogens, an R group, and an OH group. The other one should go way faster because I'm just using the chart and showing you guys how to use it too. Okay, so with using the chart, I always start by drawing this. So ethanolic acid, that's 2 carbons, 1 double bonded oxygen, 1 single bonded. And I'll add my hydrogens and hit arrange and fit. And then LAH stands for lithium aluminum hydride. So I'll go ahead and go to my chart. And let's see, I had a carboxylic acid, lithium, and aluminum. So I'm going to go down to the net product, and I see that this carbon is my focus. I'm going to make sure it has 2 hydrogens, an OH group, and the R group remains. So all I'll simply do is, I'll add an oxygen atom just to have some hydrogens already there. So I'll go ahead and release, let's see. Well, I have an OH already, so I'll just go ahead and delete this. Use my hydrolytic function to grab these 2 hydrogens. Hit arrange. And I'm going to delete that oxygen molecule. So this is the carbon of focus. I have 2 hydrogens, an R group, and an OH group. I go back to my chart. This carbon needs to have 2 hydrogens, an R group, and an OH group. So it seems to match up. I used this method throughout the whole lesson and it really, really helped me. So I'll go ahead and draw the pentane nitrile. It's 5 carbons, a double bonded nitrogen. I'll go ahead and add my water molecule. And I add that because sometimes I'm replacing the nitrogen with oxygen, and it just helps having it on the canvas already. Okay, so I'm dealing with a nitrile and aluminum, no lithium. So I'm going to go back to my chart, look for the nitrile, and I see this aluminum, but it has lithium, so I'll go to this aluminum. And I see the net reaction when dealing with this carbon that's triple bonded to the nitrogen. It has a double bond to oxygen, single bond to carbon, and hydrogen. So I'm dealing with this carbon here. I'll go ahead and use my hydrolytic function to move this away. And I'll go ahead and attach this. I know it's going to be double bonded, so I'll go ahead and bond that now. And it was just single oxygen. And then I'll go ahead and take this bond and grab the hydrogen. Hit arrange. I'm going to delete everything else on the canvas. So we're basically just trying to match up wherever the carbon's attached to the nitrogen and oxygen is where we want to match up with these pictures over here. So we see that that carbon needs to be double bonded to oxygen and have an R and an H group. And we see this carbon is double bonded to oxygen. It has an H group and an R group. Okay, let's start by drawing this. Butanoate. So, 4 carbons, double bonded oxygen, single bonded oxygen. There's an ethyl on this oxygen, so I'll add that. And at the 2 position, there's an ethyl, so over here. And then we have 2 equivalents of CH3, so I will go ahead and draw that because we're going to be adding some methyls. And this is the way you would draw these methyls and the boranes and the bromines. And a hydronium workup. So this is like kind of like mixing the 2 methods of going through it and just drawing everything rather than just going to the chart and looking and seeing how to do it. Okay, so I'm pretty sure we're going to be removing one of the oxygen groups and adding these 2 methyl groups with the OH group, but we'll go ahead and see. So we have okay. Okay, I'm gonna see if it lets me do it. I'm not sure if it will, but let's see. So I had a butanoate. I'll do it really quick. Ethyls. I had my water, my magnesium, and my bromine. Add my hydrogens and hit arrange and fit. Move this. Okay, so sorry about that. Let's see if I can check on the chart. I had an ester, and I'm reacting it with, over here, the 2 equivalents of magnesium. And see, we will be adding those 2 methyl groups, and then we're going to take away one of the oxygen groups and keep one, but have an OH. So I'll go ahead and use my hydrolytic function to remove this, to give the electrons back to oxygen. Since there's an open space, I can go ahead and remove this methyl and attach it to that carbon. I can, using the method again, I'll do a double bond to release this oxygen from that carbon. And then I'll release the electrons back to oxygen. You don't have to do that, I like showing it for the most part. And I'll add this methyl group back, hit arrange. Let's see if I can move this over. So I have my 2 R groups, the 2 methyls, and then this R group And I need to just add a hydrogen. So I'll try to take an easy one. Okay. And then I'll go ahead and delete everything else on my canvas. Let's see if hopefully it lets me submit that. So just to make sure, 3 R groups and an OH group. So let's see if it'll let me. Okay. Sorry about that. Okay, pentane nitrile, so that's 5 carbons and triple bonded nitrogen. And I'll go ahead and draw my methyl magnesium chloride. I want to say that it's drawn like this. And I'll just draw my water as well. Okay, so I'm reacting in nitrile with methyl magnesium. So I'll go back to my chart, go to nitrile, and I see we have the magnesium right here. So the end product is that carbon attached to that methyl magnesium, the methyl from the methyl magnesium, the normal attachment that was already there, and a double bonded oxygen. So I'll go ahead and just I'll just delete this. I'll bring this bond over here, delete this. I won't need this anymore. And lastly, I will need to bond this to the carbon because I know I needed a double bonded, and release these back to oxygen. And I'll go ahead and delete them. Hit arrange and fit. Okay, so the end product, I've got that one R group that I got from magnesium, the R group that was already there, and a double bonded oxygen. Going back to make sure this is what I got. That's what it looks like, so I'll go ahead and do it. We're doing pentane nitrile again. Hydrogen gas and transition metal catalyst. So I'll go back to my chart, go to nitrile, and I see H2 and transition metal catalyst. So the end product, I'm not going to draw any of the other things, I'm just going to simply do it. So I know the hydrolytic, I'll go ahead and release those bonds, add my hydrogens, hit arrange, and then I need to add 2 more hydrogens, one right here, and I'll go ahead and bond this one over here. Using my hydrolytic function. Okay, so this should be the end product. We have the carbon with 2 hydrogens connected to the R group and connected to NH2. Let's go back over here. Carbon with 2 hydrogens, our R group, and NH2. So let's check it out. Perfect. So hopefully by the end of this, we'll all know how to use the chart, and it won't be too bad during class, because I know it can be confusing. Okay, I didn't double bond it yet. Okay, propanoate, and then there's a methyl at the 2 position. Add my sodium. So this is a carboxylic salt. So let's see, it's reacting with lithium aluminum. Carboxylic salt, got that right here. So the end product will be 2 hydrogens, 1 R group, and an OH group. So I'll add my water, use my hydrolytic function. I'll remove these bonds. Actually, to save time, I could have just deleted this, so I'll go ahead and delete it now. And then I'll go ahead and grab these 2 hydrogens, hit arrange, and then I'm going to go ahead and delete everything else. And I'm going to make sure for that sodium that I don't need to keep. No, that should be good. So you can go back to the chart and make sure it matches up. 2 hydrogens, an R group, and an OH group. 2 hydrogens, an R group, and an OH group. So the most important thing here is to make sure that you draw the correct structure, because if you don't, that'll be the one that really messes up. And then also keep an eye if it says product or products. So 6. I'll add my chlorine. I did a carbon by accident, and my double bonded oxygen. Add my hydrogens and hit arrange and fit. And this is a big one here. But let's go to the chart and check it out. So we're going to look at the acyl halides and then go to, let's see what we have. Lithium tritert butoxy aluminum hydride. So I believe this is what it's going to be. Yes, because the tritert butoxy includes all these O groups, as we can see by the oxy. But if we look at the other one, this has no O groups. So we want to make sure we pick the right one as well. And the net product will be replacing that chlorine with a hydrogen. So I'll go ahead and I'm going to delete these bonds. Okay, so that should be it for this one. So that's also an important thing, to make sure that you have the right molecule that you're reacting it with. Propanamide, got my double bonded oxygen and my single bonded nitrogen. Arrange and fit. I have a primary amide reacting with just aluminum hydride, no lithium, so I'll go to my primary amide. And actually all these 3 have the same outcome. They all give you double bonded oxygen, an R group, and a hydrogen. So all I really have to do is delete this group. Oh, I should have left one of those. Okay. Let me bond that. Hit arrange. And that's all I did, was replace the nitrogen with the hydrogen, as we can see here from the chart. So you always want to make sure that if the question has lithium or aluminum or both, because there's different outcomes. Like for this one, if I picked here that has lithium, I would get something completely different. Just double check and make sure that if lithium is in the question or not. Okay, so I'll start by drawing the propane, and then I'll have an ethane right there. Right. I'll do a double bonded oxygen, a single bonded oxygen, again connect to that carbon to make a anhydride. Okay. And you see, I could already see that this is going to have 2 products because there's 2 different molecules here. in essence. If it was just showing both of them with ethane, then you should be able to only show one. So you're gonna have two outcomes, but if it only says product, then you want to delete one of them. So I'm going to go to my chart, and I have an anhydride. This is the only one that's mixed with, and yep, lithium aluminum. So I have these two outcomes. They're exactly the same, except one R group, as we saw, was propane and the other one was an ethyl. So I'll go ahead and start working on that. I'll release these bonds. I'm gonna go ahead and add my water because I want to take hydrogens from there. And I'll go ahead and take this one, bring this back, take this hydrogen, bring it back, and then I'll go ahead, I'm going to delete that molecule. And I see that my carbon only has 3 bonds, so I'm actually going to have to add a hydrogen to each of them. And it is easier if you add this to the lithium aluminum already, just because you can take the hydrogens from there, but you can also add it like I did as well. So I go back to my chart. I've got 2 hydrogens on each, an R group and an OH group. And I have 2 hydrogens here, an R group, my OH, and I have the same thing over here. So I'll go ahead and press submit. Alright, and that was number 10. So I hope this helps you guys. I didn't mean to go too fast, so I hope you're able to get it with a chart. And yeah, good luck.